Hello, welcome to this video. Unit 3 is starting. This is lesson 3-1. In this video, we're going to talk specifically about position of an object. We'll talk about velocity and then also acceleration. And we'll talk about how you can relate these three topics in your mind. I'll give you a little chart. Hopefully that can help organize the information for you. And we'll look at some examples. In this lesson, I'm going to split it into 3 different videos. The first video is just going to talk about the ideas and about the vocabulary terms that you're going to need to know. I'll do one very brief example. Video 2 is going to dive into a deeper example that incorporates all of these ideas, and then the third video will finish off the last examples. So let's go ahead and look at these terms. All right, so for position, velocity, and acceleration, the important idea here is starting out with position. So this is where we start out, okay? And this gives the location of an object at a certain time, okay? And it's generally called S of t, okay? So that's the function when you see S of t. Now, if I want to take the rate of change of position, this is known as velocity, okay? And I'll write this. This is velocity, V of t. Now, if velocity is positive, then a object is going to be moving upward or in a rightward motion, okay? And if it's negative or downward, downward or leftward, okay, leftward, that's weird, then it's negative, okay? Now, acceleration is the third of these. I'll put this in red over here, acceleration, okay? And this is A of t. Now, how do I go from position to velocity, and velocity is the rate of change of position, to acceleration, which acceleration is the rate of change of velocity? Well, again, how do we calculate instantaneous rate of change? Well, you take the derivative. Okay, good. So that's how you move from position to velocity. You're going to differentiate. Okay, and then that's how you're going to move from velocity to acceleration. You're going to differentiate. Okay, so that's how you relate these 3 ideas. Position, okay, then velocity, that's the first derivative. Then acceleration, that's the second derivative, okay? Other terms, and let me start a chart down here. Save some room for example 1, and let's see if I can save some room. I'm going to make a little chart down here like this. Okay. And I want to start out with position. Okay, so I'm going to write position. Okay, and then draw a line. Then I have velocity. Okay, then I have acceleration. All right. Okay, and then remember, just to move from 1, you're just going to take a derivative, right? So this is S of t, okay? Velocity is V of t. And acceleration, right there, I want to write it over here, is A of t. Okay, so how do I get to velocity from acceleration? Well, you're going to take the derivative. Okay, so this is F S prime of t. Okay, and then how do we get to acceleration? Well, you take the derivative of velocity, so V prime of t. Okay, well, velocity is the derivative of position. So then it's S double prime of t for position, the second derivative of acceleration. Okay, so make sure you incorporate those. Now let's go ahead and talk about some other terms that we're going to look at in this example. We're going to talk about initial position and initial velocity. Remember, an initial value is something that you have right away, like in the beginning. So what you do is you're just going to take your functions and you're going to evaluate at 0 when t is equal to 0. Now, another way that you'll see this too here, note they say s naught and v naught. Okay, that's how you pronounce that, s naught, v naught. And that's just a term for initial position. Okay, so I can write right here, so initial position. Okay, and this is when t is equal to 0. When t is equal to 0, also known as s of 0. Okay, and then we also have initial velocity. Okay, and this is again also when t is equal to 0 or v of 0. Okay, and then the last couple of terms that we have here, we have speed. So speed of an object, that's the same thing as velocity, except it's the absolute value. So velocity can speed up or it can slow down. Well, speed is just the absolute value of that. So I'm going to write right here, I'm going to write speed. Okay, and this is equal to the absolute value of velocity. Okay, so that's speed. All right, displacement. Displacement relates to position. Displacement is, you know, have you heard that phrase, how much displace, or what's the displacement of an object? So, you know, how much an object has changed. Okay, so that is for position. So here we have displacement. Displacement. Okay, and in parentheses, all this is the final position of an object. Final position, subtract the original position. Okay, that is displacement. And then the last term that we have here is total distance. So total distance, an object can, so if I was to drive to Sacramento, right, and then drive back here to Ceres, my displacement would be 0, right, because I didn't move at all. But that's not true. If I'm talking about my total distance, didn't I drive, 90 miles to Sacramento and then 90 miles back? So that is total distance, okay, and it takes into account all direction changes. So I'm going to write over here, total distance. Whoa. You try to undo that. There it goes. Okay. So total distance. Okay, and again, this is all directions. All direction changes. Okay, so that's a little chart just to kind of organize all the terms that we've been given in this lesson. I recommend flashcards so you can help memorize these things and use them cold. And I just want to look at example 1 and go ahead and use this. And this is a very basic example. This says if s of t is equal to t cubed plus t, find v of t and a of t. Well, I have s of t, so v of t, this is velocity. I know that this is the derivative of my position, so I just use the power rule, and there is v of t. It's that simple. Okay, and then they ask us what is a of t. That's the acceleration, okay, at time t. Well, that is the derivative of velocity. So again, I use the power rule, and I get 6t. Okay, that's it. All right, I hope in this video you learned something about position, velocity, and acceleration, how they're related, and then also a couple other terms relating to position, velocity, and acceleration. Catch the next video for some examples, and that's it. See you.